this video, I'm going to be discussing the forms of lines. So the forms of lines, we're talking slope intercept form, standard form, and then we're going to look at some special cases where we have horizontal and vertical lines. So before I dive into it, when I talk about forms of lines, or sometimes I talk about types of lines, and all lines are the same. All lines are straight. Lines are straight. When I'm talking about the forms of lines, I'm talking about the way we can represent those lines with equations. Okay, so what is the equation associated with a line? Okay, so there's different ways that we can make these equations look, and you'll see in future videos there's different ways we can switch from one look to another. We can change the appearance of these equations. But when it's all said and done, if you have two different equations, or they look different, they can be the exact same line, they're just represented differently, or they're dressed up different. It's the same thing. So when I'm talking about forms of lines, remember all lines are straight. They could look all kinds of different ways, going up, coming down, horizontal, vertical. We're talking about all these guys. We're really focusing on the equations that represents these lines. So let's get to it. We're going to jump into each of these four forms, and I'll identify some key pieces. So slope-intercept form is probably the most common one that students run into. You should probably remember it back in Algebra 1. It is y equals mx plus b. Okay, it's probably the most common one students look at. The reason being is it's super convenient to go from an equation to a graph. That you can just look at the equation and immediately get some information about that line and what that graph looks like. The m there, that is your slope. So whatever number shows up in front of the x variable in slope-intercept form, that is your slope. And remember, slope is your rise, so how much you're going up or down over run. So if you represent it as a fraction, how much you're going up or down, and then moving to the left, right, whichever direction, we go to the right with us. Trying to look at my camera here and it's all mirrored and stuff, whatever. So rise over run. The b, that number that you would see in those equations that's by itself, that is the y-intercept. So when you're given an equation in slope-intercept form, the equation of the line in slope-intercept form, it's very convenient because you can quickly pick out your slope, quickly pick out your y-intercept, and you can get to a graph pretty fast with just that information. That's why this one pops up so much. The other one that you're going to see is standard form. Now, it's other ways we can represent a line, and how we represent it is ax plus by equals c. So in the purposes of graphing lines and looking at lines in that way, ax plus by equals c, standard form, not super great to look at and immediately get information, okay? There are ways, tips, and tricks to figure out x and y intercepts super fast with it. If we want to dive into standard form, we could do that and look at those things. I'm not going to do that in this video. But what's neat about this is you can represent a line in slope-intercept form or in standard form. If you have it in standard form, this can be rewritten. It can be rewritten into slope-intercept form. Okay, we can change the way it looks. See, I'm off the screen there. We can change the way the equation looks, but it's still the exact same line. So a lot of times what we're going to see is we're going to be given something in standard form, and if it's not really convenient for us, we're going to switch the way it looks. We're not really changing anything, just the way it looks to go to the other one. Okay, so that's sometimes what you'll see. Other times when we're working with standard form, we're happy with the equation it's in. We do things. When we talk about solving systems, we usually leave it in standard form. The last two I want to talk about is stuff that students usually get hung up on very, very easily, and that is horizontal and vertical lines and kind of the forms they show up. So when we're talking about horizontal lines, we're talking about that. Okay, lines when they're graphed, they are horizontal. Vertical lines, we're talking straight up and down. Okay, horizontal and vertical lines. They're kind of special cases. compared to most lines that you have probably seen graphed. So what gets hung up here is students kind of forget, well, what's the equation of this line? What is the equation of this line? When given the equations, they don't know, well, I don't know, I got this equation. I know it's special, but I'm not sure if it's a horizontal and vertical line. So there is a little bit of a saying that helps you identify what equation you should be using and what equation produces what type of line, horizontal or vertical. It's also going to give us a little bit extra information as well about horizontal and vertical lines, which helps you out. So that saying that you should probably take with you, if you can't easily identify these, is HOY, H-O-Y, VUX, V-U-X. Okay, HOY, VUX. It's a short little saying that's going to give you a lot of important information really, really fast about horizontal and vertical lines. Here's what HOY stands for, and then I'll go through VUX. So the H there is going to stand for horizontal. So the following information we're going to get is all about horizontal lines. The first letter just tells you what type of line is it, horizontal. The second letter is actually going to tell you about the slope. Now this one is a little bit deceiving because that is not the letter O. In that case, it's the number 0, because horizontal lines, they do have a slope, and that slope is 0. We're not rising at all, so we're not going up or down, we're just going. So the slope is 0. And then the last part, H-O-Y. Different teachers will tell you different things. I use that as when you see the Y, that's telling you, hey, horizontal lines have the equation Y equals. Other teachers might talk to you about, well, horizontal lines, they're going to go through the y-axis. So you could take both of those with you. Those are both useful. So horizontal equations have an equation of y equals, and you're going to have some sort of number there. That's it. No x's, just a number, and then it's going to go through the y-axis. So when we're looking at horizontal lines, they're going to be of the form y equals. We're going to have some sort of number there, okay? Horizontal lines. Vertical lines is going to go with this saying, VUX, V-U-X. It's going to tell us the same three things. It's going to tell you what type of line, tell you about the slope, and give you some information about the equation and the axis. So you could probably figure things out here. The Z stands for vertical, so VUX is going to teach you everything about vertical lines. The U is going to tell you about the slope. Vertical lines, they do not have a slope. It is not defined. So what we call that is we call it undefined. Okay, undefined. And then the X part is going to tell you about the equation. It's going to be X equals some number. So when you see X equals some number, for example, like X equals 2, I should be thinking, hey, that's a little bit different. But if I think about VUX, I know, hey, this represents a vertical line, and I already know it's going to have a slope that's undefined. Now, the other thing teachers teach is that X for VUX does stand for x-axis. So this graph is going to go through and intercept the x-axis. When I talked about y-axis up there, it's going through the y-axis is kind of the thoughts there. So that is our 4 forms of lines we're going to kind of focus on and make sure we know along their way. There are other forms, but these are the ones we're going to focus on that you really need to know.